Hey guys, in this video we're going to talk about vertical motion. This is the third video in our 4-part series about motion. And before we begin any motion, before any motion lesson, we need to discuss key terms. So, when an object is dropped, the initial velocity equals 0. When object falls from rest, the initial velocity equals 0. If an object falls and doesn't mention initial velocity, assume initial velocity equals 0. So, if an object is thrown downward with a velocity, the initial velocity equals that velocity, which we'll usually tell you in the problem. Is that pretty much what that means? So, acceleration of vertical motion down is G equals positive 9.8 millimeters per second squared. Alright? And so, there's a little diagram I'm going to fill out for you guys to help you hopefully visualize what this is saying a little better. So, we're going to start, these are balls, okay? Or an object, but they're circular, so I think they're balls. So, I'm going to label them A, B, C, and D. And this little part right here is the ground when it hits, okay? So, initially, VA, which is velocity of A, equals 0. So, time also equals 0. Alright? Since it hasn't dropped yet, and there's no velocity yet. Alright? And so we have velocity B equals 9.8 meters per second, and the time equals 1 second. Okay, so the 9.8, that is the acceleration. That is what is measured to understand velocity B equals 9.8 meters per second squared, and our time in this situation equals 1 second. Alright, as it states up here, the acceleration of a vertical motion down is 9.8 meters per second squared. So this is the first increment of it going down, so it's going to equal 9.8 meters per second squared. Alright, so next we have velocity of C, which, since we're doubling, alright, this is another second going by, alright? So it would be 9.8 plus 9.8. So the velocity of C is 19.6 meters a second. And then our time, since we're adding another second, is just 2 seconds. Alright, so next we have the velocity of D. So this is another one that we're going to have to add 9.8. So 19.6 plus 9.8 equals 29.4 meters per second. And finally, our time equals 3 seconds. Alright, so our next diagram, object is thrown with an initial velocity. So this means that the object that is being thrown has it's not being dropped. It has force going behind it to that it starts at. It has a force that it starts at just with a measurement. So instead of it being 0, once again, imagine this is A, B, C, D. So velocity A equals, I'm just going to say in this case, 10 meters per second. All right, next we have velocity B, which equals, all right, so as I previously mentioned, so we're talking about our initial velocity here, and we have our acceleration. For each increment, we have to add 9.8 to get that velocity of where that object was in that time. So what to do here is that you would add 9.8 to 10. So it would be, in this case, 9.8 meters per second. I'm not going to worry about the time in this one because I'm pretty sure you got it here. And so for our next second, velocity C, once again, we're going to add another 9.8. I'm going to do this. So 9.8 meters per second. And so that's going to give us 29.6 meters per second. All right. And finally, to get velocity D, we're going to add another 9.8 meters per second. All right. So velocity D is going to equal 39.4 meters a second. All right. So essentially, this is a demonstration to show you that the acceleration in each increment needs to be added to find the exact location of where the object was in that instance. There's some examples we're going to show you kind of what this means. All right. So now on to our examples. A ball is thrown downward at 12 meters per second and falls 37 meters before hitting the ground. With what velocity did the ball strike the ground? All right. First, before we begin, let's draw our diagram. All right. So this is the ball, and this is the ground. Okay. So the ball is thrown downward. So at 12 meters per second. This is our initial velocity. It's where it starts. So then it falls 37 meters. Falls 37 meters down to the ground. And so finally ask, with what velocity did the ball strike the ground? So in this situation, we're going to be looking for the final velocity. All right, once again, we're going to make our chart. We have the initial velocity, the final velocity, we have the distance, the acceleration, and the time. Okay, so the initial velocity in this situation is going to be 12 meters per second. Our final velocity, which we don't know, which we're looking for, is going to be our question mark. The distance is going to be 37 meters. And as we discussed in our brochure, the acceleration of a vertical motion down is 9.8 meters per second. So the acceleration in this case is going to be 9.8 meters per second. All right, and then the time we're not going to worry about, so we're just going to put a dash. So now we need to look back at our pamphlet to look at our different equations. So we need to look with one that does not include time. So we have to immediately eliminate 4 and eliminate 2 and eliminate 1. So the only option that leaves us is with equation number 3, which is the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the distance. All right, so we have the final velocity squared equals 12 squared plus 2 times the acceleration, which is 9.8, times the distance, which is 37. All right, so I'm going to plug this into my calculator. So we have 12 squared plus 2 times 9.8 times 37. And that gives us 869.2. And now we have to square both sides. All right, so we have the final velocity equals our final velocity equals 29.4 meters squared. Okay, so I understand that usually when you square root something, it gives you have the option of positive or negative. In this situation, you just use the positive, okay? So our final velocity is a positive 29.4 meters per second. And look at our next problem. So the question asks, a ball is thrown downward at 11 meters per second and strikes the ground at 65 meters per second. How far downward did the ball travel? So once again, let's go ahead and create our diagram. So we have our ball, and it's being thrown downward. Okay, so it says here that the ball is thrown downward at, so our initial velocity is going to be 11 meters per second. And our final, it also says here, and strikes the ground at 65 meters per second. So our final velocity is going to be 65 meters per second. And the question asks, how far downward did the ball travel? So how far usually indicates we're looking for distance. So in this situation, we're going to look for distance. Okay, so next we're going to look for the initial velocity, the final velocity. Oh, we actually already have those. The distance, acceleration, and the time. All right, so the initial velocity in this problem is 11 meters per second. The final velocity is 65. Nope, not meters per second. Is 11 meters per second. And the final velocity is 65 meters per second. Our distances are unknown. Once again, our acceleration of a vertical motion downward is 9.8 meters per second. So it's going to be 9.8 meters per second squared. And then the time is not necessary for this problem, so we're just going to put a dash there. Okay, so now once again, let's go ahead and look at our motion equations. So we need to look for a problem that doesn't include time. So this one includes time, this one includes time, this one does not include time, and this one includes time. So our answer is going to be motion equation number 3. So VF squared equals, or final velocity, excuse me, the initial velocity squared plus 2 times the acceleration times the distance. Okay, so our final velocity is 65, which equals initial velocity, which is 11 squared, plus 2 times the acceleration times the distance, which is our unknown. Okay, so 65 squared equals 11 times 11 is 121 plus 2 times 9.8, which equals 19.6 times the distance. All right, so now I'm going to quickly find 65 squared. That is 402.25. And then we're going to subtract both sides by 121. And that's going to equal 4104, which equals 19.6 times the distance. And now if we divide both sides by 19.6, our distance is going to be equaled 4104 divided by 19.6 equals about, I'm going to say 209 meters. Okay, so for our next problem, if a stone is thrown downward at if a stone is thrown downward, for our next problem, if a stone is thrown downward at 9.5 meters per second, how far will it fall in 9 seconds? So let's make our diagram. We have our stone here. And if it's thrown downward at 9.5 meters per second, so 9.5 meters per second, and that's our initial velocity, and it's being thrown down, and we know that it's asking us to find out how far it will fall in 9 seconds, so we know what time we're looking for. So time equals 9 seconds. And it's asking how far, so we're gonna look for our distance. We're gonna look for a distance. Okay, so we know that our initial velocity is 9.5 meters per second. We don't need a final velocity, so we're gonna put a dash. Our distance is our unknown. Our acceleration of a vertical motion down is 9.8 meters per second squared. So it's going to be 9.8 meters per second squared. And then our time is 9 seconds. Okay, so let's go ahead and look at our equations. And now we have to look for one that does not include final velocity. So the first one is final velocity, so we wouldn't use that one. The second one does not have final velocity. The third one does, so we're not going to use that. And number 4, we're not going to use because the acceleration does not equal 0. So we're going to use number 2. And the equation for that is distance equals the initial velocity times the time plus half the acceleration times the time squared. So if we plug that in, distance equals 9.5 times 9 plus half the acceleration, 9.8, times the time squared. Okay, so the final distance, I'm just going to plug everything into my calculator because I have no variables on the right side of the equation. But 9.5 times 9 plus 1 divided by 2 times 9.8 times 9 squared equals, I'm going to round up to, or I'm going to round down to 482. So 482 meters is how far it will fall in 9 seconds. All right, hope you found this video super helpful. We'll be making the next one. Thank you very much and have a great day.